Okay, so if you can remember, we started this chapter where we were graphing parabolas, okay? Remember, these are parabolas, which means they have an x squared in the equation. They're no longer straight lines. They're no longer y equals mx plus b. They're y equals x squared, okay? So what we can do is look at this picture, and there's a bunch of characteristics that we need to answer, okay? Characteristics meaning, like, where is the vertex? Where is the axis of symmetry? What else did we have to know? Where is the, or what is the domain? What's the range? And if there's a max or a min. Okay, so vertex. Your vertex is a point. It's something, comma, something. And it is either your highest or your lowest point. Your axis of symmetry is a line, but let's do your vertex first. Does someone think they can raise their hand and tell us what, comma, what is the vertex in this picture? It's the highest or the lowest point. Owen. -1, comma, -2. Good job. So your vertex is right here, right? It's your highest or your lowest point, which is that point right there. Okay, your AOS. Your AOS is an imaginary line where if I were to fold the left side onto the right side, both sides would like match each other. Melanie, what do you think? Oh my gosh, you are so good. Yes. Ah, shouldn't it be -2, -4? Silly rabbit, because look, they're not counting by, hold on, 2, 4, 6, 8, yeah. So bad. Okay, so do you see how they're not counting by 1? So yes, technically it would be -1, -2 if they were counting by 1s, but technically they're counting by 2s. Good eye, good eye. So it's actually -2, -4. Thank you. All right, AOS is an imaginary line. Does anyone think they know what would the AOS be? Vaughn, what do you think? Good, -2, right? Do you see how it's this line right here? So it's at -2, but remember -2 is a number. I need a line, so it's something equals -2. Is it x equals or y equals, guys? X, right? Because it's a vertical line. So it's one of those things where like, it's always the opposite. When we want to name lines, you would think vertical is y because that's like the y-axis, but it's always flipped. So vertical lines are always x equals, horizontal lines are always y equals. All right, domain. Does someone online think they can tell us what's the domain for this problem or this picture? Online kids, do you know?
All real numbers.
Thank you. It's all real numbers. So why is it all real numbers? Because remember, domain is x. Your alligators, your inequalities always e to the right. So how far to the left do you go? -infinity, because the arrow keeps on going to the left. How far to the right do you go? +infinity, because you go to the right. So if you have infinities on both sides, you don't write that. You write all real numbers. Good job. Okay, range. Does somebody online know what the range is? Range is y. It's up and down.
All real numbers greater than -4.
Very good. All real numbers greater than -4. Basically, y is greater than or equal to -4. So I already know without doing like this alligator thing that Kip is right. And the reason why I know that is because look, do you see how all my picture is above the -4? So I already know above means it's greater than. Below means it's less than. So it's greater than, but what is the lowest point? -4. Or I can say to myself, okay, I have y. My alligators always eat this way. So how far low do I go? -4. How far high do I go? Infinity. If I have infinity on one of the sides, it would be y is greater than or equal to -4. That's how I got this answer. Or rather, that's how Kip got that answer. Okay, finally, in-person kids, maximum, minimum. What point does this picture have? A max or a min?
A minimum.
Minimum. Thank you. Right. Minimum means it's the lowest point. Maximum means it's the highest point. Okay. So that's the first thing you need to know about these graphs. What are their characteristics? Okay. So let's do the next one then. Let's graph this one. Compare the graph of that. So since we have so much room, let's just sketch it out. We don't need our actual graph paper. Okay. So maybe go like 5 on the right, 5 on the left, 5 to the top, 5 to the bottom. Okay, so we want to compare it to the parent function being x squared. So x squared means, remember, you have 0, 0. That's your vertex. You go over 1, up 1, over 1, up 1. And the reason why you're going over 1, up 1, because x squared is 1x squared. That's why you go up 1. So that is my parent function. Now what I want to do is I want to compare it with 3.5x squared. So 3.5x squared, I still have my vertex at 0, 0. I'm going to go over 1. How many am I going to go up, though? 3.5, 3.5 tick mark. So I'll go 1, 2, 3.5 tick mark over 1, 1, 2, 3.5 tick mark, like that. So this would be my picture here. So that's how I can graph it by hand. If you guys don't remember how to graph it by hand, then remember what we said, what you can do. You can just put it in your calculator. So your calculator, if I can find mine, I can't find mine right now. Let's see if this one still has batteries. This one, oh, no, okay. But you can just go to the y equals, type 3.5x squared, and then be able to, whatchamacallit, just do it that way. Okay, go to the table, plot the points. That's okay too. Okay, but now we have to compare. So compare saying we have to say a couple things about them. So stretching and shrinking. So first of all, would this be a stretch, do you think, or a shrink? A stretch. So the reason why I would say this is a stretch is because do you see how this number, and this is kind of what we took notes on Friday, this number is bigger than 1, right? Do you see how 3.5 is bigger than 1? So I already know then that it's a vertical stretch of 3.5. If the number here were between 0 and 1, if it was like 1/2 or 1/4 or 2/3 or whatever, then it would be a shrink. If that doesn't make sense to you, or if you forgot that rule, remember you can think to yourself, okay, if I put my fingers on this parent function, aren't I stretching it up skinnier to make it skinnier? So that's why I'm stretching it. I'm not shrinking it. I'm not making it fatter. I'm making it skinnier. That's why it'd be a stretch. Okay, the next thing we have to say is the opening. So do you see how both of them open up? So I would write both open up. So both open up. All right, next thing we have to talk about is the AOS. Are they the same or are they different?
Different.
Same. They'd actually be the same. Do you see how my AOS, if I were to take the green picture and fold it on this pink line right there, both sides would meet. But if I also were to fold it on the orange picture, both sides would meet as well. So the AOS is actually the same. So what is it? 0, but what equals 0? X equals 0. The AOS is the same for both. They're both at x equals 0. Please remember, it's always a line, not just a number, okay? Next thing we have to talk about is, did it reflect over the x-axis? What do we think? No, right? Because if it reflected, the green would be pointing down. And that's all we have to talk about. Okay, so let me clarify. So let's take out our level work. And I'm going to have the answers on my table, or that table over there where they normally are. But let me clarify for you online kids who aren't going to stay on right now, what exactly I'm looking for, okay? And I think I'm going to do that really big word problem with you, just so it's a little bit easier to understand. Okay, So it says in exercises 1 through 6, graph the function, compare the graph to the parent function, be sure to pick up graph paper. So guys, remember, if you are in person, you could be using one of your graph papers right now. If you are online, what you can do is you can Google graph paper, or you can go to Schoology, and when you open up RC3, there's that you can print off or do it on Kami. Or if you just open up your math course, it's also right there. So I have the graph paper up in 2 places. Okay, so either do it on Kami or print it out, and then you can draw on it. Okay, if you don't have graph paper at home. Okay, so what you're going to be doing is you are going to be graphing all of these and then saying what the like comparing. So when we compare, can I just do let me just do one of them with you. Let me do number 2 with you, okay? Because it's different than your starter. So I'm going to do number 2 with you. Okay, so it says to graph it. So let's go ahead and graph it. So draw yourself an XY axis. Let's graph our parent function. Vertex in the center, up 1 over 1, up 1 over 1. Okay, now I have to graph 0.25x squared. So if I'm graphing 0.25x squared, I still have 0, 0 as a point. I'm going up how many squares? 0.25, in other words, 1/4. Okay, 0.25 is 1/4. So 1, 2, 3, 4, 1, 2, 3, 4. So here's 1/4 of a square. Basically, I broke 1 square up into 4 pieces, right? So here is my new picture. And again, if you don't want to do that, what you could do is you could also just put it in your graphing calculator. So you could say, go to the y equals 0.25x squared like that, hit graph, that's your picture, and then you can go to your table and get the points that way, whatever you want. Okay, but it literally is the same thing. Okay, so that's me graphing it. Now what I have to do is I have to compare. So what I did on my starter. Okay, so first of all, whenever I compare, I'm talking about the stretching or the shrinking. So did this stretch or did this shrink? Shrink. The reason why I know it shrunk is because this number is between 0 and 1. Or I can say it got fatter, right? If it got fatter and wider, then it shrunk. So I could say this is a vertical shrink of 0.25. So that's the first thing I always talk about. It's stretching and shrinking. The next thing I talk about is their openings. Do both of them open up? Yes. So I'm going to say both open up. Okay. What about my AOS? Are they the same or are they different? Same. So I write same AOS, which would be what? What equals 0? X equals 0. Good. Not just a point, not just a number, but a line. X equals 0, right? My AOS is this imaginary line right here, where I can fold it and both sides would touch each other symmetrically. Last thing I can talk about is the reflection. Did it reflect on the x-axis? No, so I just write no reflection. But if there were a reflection, then you would have to write that there was a reflection. So there are 3 of them in these 6 problems that have a reflection. So you would have to write there's a reflection. Okay, so that's what you're doing for numbers 1 through 6. You're going to talk about these things for every single one. So every single one will have 4 answers. Okay, then it says describe and correct the error when you want to compare these two. I think you can do that. Okay, let's talk about this one though. This one's a big one. Number 8. Okay. The arch support of a bridge can be modeled by blank, where X and Y are measured in feet. The width of the arch is 900 feet. Describe the domain of the function. Okay, so let's just kind of sketch this out, okay? So if I were to sketch this out, -1 over 300x squared. So I know my center is at 0, 0. Just by looking at this picture, is it going to open up or open down? Down. What tells you that this is going to be down? The negative. So let me just sketch. I mean, you're technically what, going 1/300th of a square, which is tiny. So it's gonna be super wide and it's gonna go down because it's negative. Okay, but it's telling you right now that this is an arch. An arch is like a curve, kind of like the underneath of a bridge or something. Okay, or like the underpass. The width of the arch is 900. So if the entire width is 900 and all of this is symmetrical, how many does it go to the left and how many does it go to the right? What did you say? Well, the whole thing is 900 from here to here. 450. Does that make sense? If all of this is symmetrical, so it's even on both sides, and all of this is 900, then wouldn't that make this negative 450 and positive 450? Because all of it, 450 plus 450 gives me 900 total. Okay, so let's find the domain. I'm telling you right now that the domain is not all real numbers. And the reason why it's not all real numbers is because this is like a word problem. They're actually giving me a parameter. If this was not a word problem, sure, the domain is all real numbers. But it's not, because your domain goes from something and it goes to something because there's an arch. So what do we think? From what to what? Right, because you see how they're telling you that the arch is 900 wide. So if it's 900 wide, how much was on each side? Negative 450 to positive 450. Okay. Describe the domain. Well, we just did. And then explain why. If you want to write in a sentence why you know it's negative 450 to positive 450, that's fine. But I feel like this picture kind of explains why too, right? You just cut 900 in half because it's symmetrical. Okay, so graph your function. So we just did. Find the height of the arch. So how tall is it? Well, if you know your x's are at 450s, then what is your y? Because don't you want to know how tall it is? And it might not be at 0, 0. Because don't you want to know like how tall this is right here? So couldn't I technically just go, okay, here's my equation. Y equals negative 1 over 300 x. When my x is at negative 450, what is this point right here? What is this y? Right? Don't I want to know what this number is? Like this point? To figure out how tall it is from 0 to what? So I'm going to plug in one of them, either negative or positive, 450, and then squared. So let's go ahead and type that in our calculator. So yes, we need calculators from now on. Okay, so alpha y equals negative 1 over 300 times negative 450 squared. Remember, whenever you replace an x with a number, you always put it in parentheses. What did you guys get? Negative 675. Okay, does that make sense that when I plugged in my x, which I knew was negative 450, that this is negative 675? Like that's essentially what we figured out. This point right here at the edge of my arch is negative 450 comma negative 675. I knew that it was negative 675 because I plugged in my x into my equation. So if this is as far low as negative 675 and it goes up to 0, how tall is this entire thing? 675 feet, right? From negative 675 to 0 is just 675 feet. Okay. Number 9, I'm going to do with you as well. A parabola opens down. Okay, so let's draw a parabola that opens down. And it passes through the points negative 3 comma 4 and 1 comma negative 2. Okay, so maybe we should sketch this out then. Negative 3 comma 4. Draw a dot. And 1 comma negative 2. How do you know that negative 3 comma 4 has to be the vertex? Like, so they're saying one of these are the vertex. And since I know it opens down, this one has to be the vertex. So I'm not going to answer that. Yeah, I think that I've kind of made it clear maybe what they're asking you. How do you know that this point out of these two have to be the vertex? This one has to be the vertex. if I know that this picture opens down. So just write as a quick sentence how you know that. And then guys, for number 10, let's just skip number 10. Yes, Tessa?
Can you go over like on the front one with the fraction?
Sure. So like number 3?
Yeah.
So 7/2 is a fraction is 3.5.
Okay, so you just change it?
Yeah, so wouldn't you go up 3.5 squares?
Yeah.
So like this one, 5/3 is 1.6. So wouldn't I go down, because it's negative, down 1.6 squares?
Yeah.
Does that make sense?
I just didn't know if there was a.
Nope, that's it. Okay. I think you should be able to do the rest by yourself.